Hello, this is Farhan Shakil from the Republic 2.0, and today we're going to talk about May 2025 Pure 1 Edexcel Maths paper. So the first question is that we have been given the value of P, that is 1 by 16 times x to the power of 4, and Q is 40 upon x cubed. And we just need to write them in the form of k x to the power of n, where k and n are fully simplified constants. Fully simplified constants are the key terms over here. So you've got p to the power of 1 by 2. So in the question number 1, you have got p to the power of 1 by 2. I'm just going to plug in the value of p, and that is going to be 1 by 16 x to the power of 4 to the whole power of 1 by 2, right? This power 1 by 2 belongs to both 1 by 16 as well as x4. So I can write it like 1 by 4 x square whole square to the whole power of 1 by 2. This 2 and 2 would get cancelled out, and you would have the final answer as 1 by 4 x square, right? Where k is 1 by 4 and n is 2 are the fully simplified constants. Now, similarly, in the second part of this question, you need to times pq to the power of negative 1. So first of all, you've got pq to the power of negative 1. I'm just going to plug in the value of p, that is 1 by 16 to the power of 4 times 40 upon x cube to the power of negative 1. So first of all, I'm going to simplify whatever I've got in the brackets, and I would be having, 4 times 4 and 4 times 10, 2 times 2 and 2 times 5. This and this would get cancelled out, and you would just be having 5x divided by 2 to the power of negative 1. I need the power to be the positive, so I can just simply write it like 2 upon, I'm just going to reciprocate that, so 2 upon 5x. So that is how we're going to get ourselves the final answer of this thing. Now you've got the second C part, and in the C part, you need to times P by Q square. So P is again 1 by 16 to the power of x to the power of 4 times Q square. Q is 40 upon x cube, so 40 upon x cube squared. And now we would be having something like x4 upon 16 times the square of 40. The square of 40 is going to be 1600 divided by x to the power of 6. So now I would be having something like 16 ones are 16 hundreds are, and this would get cancelled out. So I must be having 100 upon x square. 100 upon x square, which can be simplified as 100 x to the power of negative 2. That is how we're going to write this thing, and for this one and for this one as well. Now, we have got this question number 2. In the question number 2, we've got a curve that is y is equals to 2x to the power of 5 by 2 minus 4x plus 3. We need to find dy upon dx, writing our answer in the simplified form. So for the A part, we are just looking for dy upon dx, right? So I'm just going to write my expression. It is being given that y is equal to 2x to the power of 5 by 2 negative 4x plus 3. I'm going to differentiate the expression on both the sides. So I would be having something like dy upon dx is equals to 2 times 5 by 2 times x to the power of 5 by 2 minus 1. Negative 4 times 1, and the differentiation of 3 is going to be 0. So now I would be having something like dy upon dx is equals to this 2 and 2 cancels out, and you have got 5x to the power of 2 times 1 is 2, 5 minus 2 going to be 3, so 3 upon 2. So I've got 3 upon 2 negative 4. That is the differentiation of the given curve. Now, the point P lies on the curve. The x coordinate of P is 2 to the power of k, where k is a constant. The gradient of C at the point P is 16. So if the gradient is 16, so what I'm going to do, I'm just going to plug in dy upon dx equals to 16 equals to 5x to the power of 3 by 2, take away 4. Since x was given as 2 to the power of k. That is the x coordinate at this point. I'm just going to work this thing down. 16 is equals to 5 times 2 to the power of k to the whole power of 3 by 2. Take away 4. And I'm going to swap this 4 onto this side. 16 plus 4 would eventually become 20. And 5 times 2k to the power of 3 by 2. And now I'm just going to simplify that. So 20 upon 5 is equals to 2 to the power of, I'm going to multiply this power with the power. So it must be 3k upon 2. And now it is going to be 4 is equals to 2 to the power of 3k plus 2. I can also write 4 as the square of 2, 2 to the power of 3k upon 2. Now we have got the same basis, so I can equate the exponents. So 2 is equals to 3k divided by 2, and 4 is equals to 3k. So k comes out to be 4 by 3. That is how we should look for the final answer for k, right? In the question number 3, we need to find the integral of this expression, and we need to write them in the simplest form. So first of all, I've got something like x plus 3 ka square, x plus 3 square divided by 3 root of x times dx. I'm going to expand the above expression. So expanding this expression, I would be having x square plus 9 plus 6x, right? Divided by 3 root of x times dx. Now I'm going to, write 3 root of x under everything. So I must be having x square divided by 3x to the power of 1 by 2 plus 9 upon 3x to the power of 1 by 2 plus 6x upon 3x to the power of 1 by 2 times dx. And now what I would be doing, I've got this expression, I'm going to simplify that. So it must be x square minus 1 by 2 divided by 3 plus 3x to the power of negative 1 by 2 and plus 2x to the power of 1 minus 1 by 2. Simplifying it further, I must be having something like x to the power of, 2 times 2, 4, 4 minus 1 has to be 3, 3 by 2 divided by 3 plus 3x to the power of negative 1 by 2 plus 2x to the power of half times dx. Now I'm going to separate out the integrals. So I must be having something like 1 by 3 x to the power of 3 by 2 dx plus 3 x to the power of negative 1 by 2 dx plus 2 x to the power of 1 by 2 dx. So simplifying it further, I must be having something like x 1 upon 3, applying the power rule of integration, 3 by 2 plus 1 divided by 3 by 2 plus 1. Similarly, plus 3 x to the power of negative 1 by 2 plus 1 and negative 1 by 2 plus 1 plus 2 x to the power of 1 by 2 plus 1 divided by 1 by 2 plus 1 and plus the constant of integration. After working this thing down, I must be having something like 1 by 3 x to the power of 5 by 2 divided by 5 by 2 plus 3 times x to the power of 1 by 2 divided by 1 by 2 plus 2 x to the power of 3 by 2 divided by 3 by 2 plus c. So further simplifying it, all these denominators would get multiplied by the numerators. So I must be having 2x to the power of 5 by 2 divided by 15 plus 6x to the power of 1 by 2 plus 4x to the power of 3 by 2 divided by 3 plus c. So that is the final answer for this constant for this integration. Now we have got this question number 4, a very important question. We have got this curve, and this is the curve of equation y is equals to 4 cos x. So if this is y is equals to 4 cos x, the maximum value of y-intercept that we can have is going to be 4, and the value over here has to be negative 4 because, cos x ranges from negative 1 to 1, right? So 4 times negative 1 going to be 4 and 4 times 1 going to be sorry, 4 times 1 going to be 4, and 4 times -1 going to be -4. And now the maximum value must be at, this is x0. This has to be 90. This has to be 180. And this has to be 270. And similarly on the negative x-axis as well. The point P and Q lies on the curve are shown in figure 1. State the coordinates of P and the coordinates of Q. So first of all, if you're looking for the coordinates of P, x is going to be 270, and y coordinate, you can easily see that since it is the x-intercept, the y coordinate has to be 0. So the coordinate of P comes out to be 270 and 0 degrees. Now similarly, we need to talk about the coordinates of Q, this one. Y coordinate has to be -4, and if you're talking about the x coordinates, this is 0, this is -90, and this has to be -180. So it is going to be x is -180 and -4. That is how you're going to talk about the coordinates of Q. Now state the number of solutions of the equations 4 cos x to 3, 5 plus cos x is equals to 1 from this to this, and 4 cos x minus 3 is equals to 1. So first of all, if you think about that, remember that up till 0 to 360 degrees, this is 360 degrees, we've always got 2 solutions of cos x, right? So now we're just going to look at how many 360 degrees are there in these ranges. So we have got 0 to 18,000, right? So C first part. So 18,000 divided by 360 comes out to be something like 0, cancels out by 0. And then you've got 0 as it is, 1 and 2, and then 100. Yeah, it must be 50. So we have got 50 revolutions over here, right? And in one revolution, we've got 2 intercepts of x. So what does that mean? The total number of solutions? The total solutions comes out to be 2 times 50, and that is 100. So we have got 100 solutions of this equation from 0 to 18,000. Now for the second part, you have got 5 plus cos x. Same is the case with this one. In one revolution, we've got almost 2 solutions. So minus 720 to 720, it almost is 720 plus 720 is going to be 1440. So 1440 divided by 360 degrees comes out to be 4 revolutions. So if you have got 4 revolutions over here, the total solutions are going to be just 2 times 4, and that comes out to be 8 solutions. So we have got 8 solutions in this part. Now similarly, if you look into this thing, minus 1080 and 1080, we just need to find out the number of revolutions we've got. So for the C third part, 1080 plus 1080 has to be 2160, right? And how many intercepts, how many revolutions we've got? 360. So it must be something like 1 and 1 and 6 revolutions. And if you have got 6 revolution, and every revolution you must be having 2 answers of cos. So the total number of solutions that we can have are going to be something like 2 times 6, and that comes out to be 12 solutions, right? So that is how we're going to do the first 4 questions of this latest Edexcel exam. In the next video, I'll come back to you guys to start the paper from question number 5. Thank you very much. If you've liked the video, please share and subscribe. Shakil from the Republic 2.0, and in the last video of this paper, we've discussed the first 4 questions of Edexcel May 2025 exam. So now we'll start the questions from the question number 5. And the question number 5 is, you've got this question number 5. The line L1 has equation x minus 2y plus 25. The L2 passes through the origin and is perpendicular to L1. So if it is perpendicular to L1, the slope of L2 should be the negative reciprocal. And we've already got the point, which is the origin. So I'll just write this equation in y is equals to mx plus c form. So to write this equation in y is equals to mx plus c form, we've got x plus 25 is equals to 2y. So y comes out to be 1 by 2x plus 25 divided by 2. That is the value of y. Once you've got y, you've got the gradient of over here, and that comes out to be 1 by 2. You've got this m, and that is equal to 1 by 2. But the slope of L2 is going to be the negative reciprocal, which has to be negative 2. So you've got the slope, and now you can easily get the equation by using this form: y minus y1 is equals to m times x minus x1. Since it is passing through the origin, so y take away 0 is equals to negative 2 times x minus 0. So you comes out to be y is equals to negative 2x. That is how you'll get the equation of L2. Once we've got the equation of L2, in the B part, he's telling us that L1 and L2 intersect at the point P. Use algebra to find the coordinates of P. So we just need to simultaneously solve the equations. And the equations are this one, which is L1, this is which is L2. I'm just going to equate them, and I've got negative 2x is equals to 1 by 2x plus 25 divided by 2, right? I'm just going to solve this equation to get myself the value of x. So negative 2x is equals to 2x plus 25. I'm going to multiply 2 on both the sides. So I must be having negative 4x equals to x plus 25. And then you must be having negative 4x negative x equals to 25. And from here onwards, negative 5x should be equal to 25. And x would be equal to 25 divided by negative 5, which comes out to be negative 5. So that is how we'll get the value of x. And once we've got the value of x, we can easily get the value of y as well by plugging this value of x into this equation. So you must be having y is equals to negative 2 times negative 5, which comes out to be 10. So that is how you'll get the value of y. So you've got x and you've got y. So you've got the point as well, and that is negative 5 and 10, which is the point of intersection. In the C part, hence, find the shortest distance from L2 to the origin and write your answer in a fully simplified set. So we need to find the shortest distance, and one should know that the shortest distance has to be the perpendicular distance between the two lines. So first of all, for a better understanding, I'll somehow plot the equations. The first equation was y is equals to 1 by 2x plus 25 upon 2. So the x-intercept of this equation is going to be something like, negative 25, something like that. And the y-intercept has to be 25, yani 12 upon 5. 12 upon 5. So this equation must be somehow looking like this. Now the other equation is y is equals to negative 2x. So it must be perpendicular to this one, somehow like this. So this point of intersection, which is a common point of both the L2 and L1, and that was negative 5 and 10. We just need to calculate the distance of negative 5 and this point from all these things, and that is 0 and 0. So OA, right? So we just need to calculate the distance from OA. So OA is going to be x2 minus x1 ka square plus y2 minus y1 ka square. We just need to calculate their distances. So I've got negative 5, negative 0 ka square plus 10 minus 0 ka square. So OA comes out to be negative 5, yani 25, 10 ka square, that is 100. So OA comes out to be root of 125. If you want to simplify it further, you can write it like root of 5 times 25, which is basically the root of 5 times 5. And that comes out to be 5 root of 5. So that is how we're going to talk about this question. Now we've got the next question. And that is that we've got this area The shaded area in the figure 2 shows a plan view of helicopter landing pad. The area consists of a major sector AOB, a circle O joined to a triangle AOC. Given that AO, and OB is 15 meters, so this is 15 meters, and you can see this is 15 meters as well. Apart from that, BC, this is 2 meters, right? CBO is a straight line, and the angle ACO, is 0.6 radians. Now, right after this thing, you've got the angle as 0.6 here. Show that the angle COA is 1.847 radians to 3 decimal places, right? So how would you do this question? You just need to calculate the angle over here, COA, the angle over here. So you can just simply apply the sine rule over here. You need to look for this angle theta. You need to find out this theta. You've got this 0.6. You've got the length of this side as well, and that is somehow 17. You've got the length of this side as well, and that is 15. And you've got the angle, which is 0.6 as well. So you've got all these angles. The 0.6, the opposite side of 0.6 is 15, and the opposite side of 17 is this angle. So first of all, you'll calculate this angle, which is alpha, and then you'll get the angle at O as well by just taking away both these angles from 180. So what you're going to do now, you just need to apply the sine rule. That has to be 0.6 divided by sine 15. Sorry, yeah. You've got the side 15 divided by sine 0.6 is equals to this side, which is 17. 17 divided by sine alpha. And you can easily get alpha from here, as alpha is equals to, sine alpha is equals to 17 times sine 0.6 divided by 15. Whatever answer you get for this expression, your alpha has to be the sine inverse of 17 times sine 0.6 divided by 15. That is how you'll get alpha. And once you have got alpha, you just need to, for theta, theta must be equal to pi minus 0.6 and whatever value of alpha you get. And whenever you're going to take them away, you must be having the angle over here that should be 1.847. So the angle over here has to be 1.847. So by having this angle, we've got the opposite angle as well, right? This one, by just taking it away from 2 pi. So this angle must be 2 pi negative 1.847, whatever it comes out to be. So after this thing, we need to find out the total area of the landing pad. How can you get the total area? In the B part, the total area would be the sum of the area of the triangle and the area of sector. How would you calculate the area of triangle? 1 by 2 sides. You've got 17 and 15. 17 times 15, and the angle between them is sine 1.847 plus. Now, if you want to calculate the angle of the sector, you must just be using 1 by 2 r squared theta. The radius of the circle is 15 square, and the theta is going to be 2 pi, take away 1.847. You just need to add them up, and you'll get the area of sector, right, in the B part. Now, if you're looking into the C part, find the perimeter of the helicopter landing pad. We need to find the perimeter. And how can we find the perimeter? We need to have this side, and we need to have the arc length of this circle, and this side is already given, that is 2. So how could you easily get that? You've got AC, right? You've got AC, and that AC comes out to be something like, you can just simply use the cosine rule over here. AC can be the B square. B square is equals to A square plus C square minus 2AC sine the opposite of 1.847, right? So we just need to plug their values in, right? And you've got B square is equals to A, that is the 15 and this side, which is going to be 17. So 15 square plus 17 square minus 2 times 50 times 17 times 1.84 7. By sorting this thing down, you'll get B. And to have this angle, you can use L is equals to R theta. So the perimeter is going to be 2 plus the side that we had, the B square, the B, and the B is going to be the square root of 15 square plus 17 square minus 2 times 15 times 17 times sine of the angle in between them, that is 1.847, right? And then we need to add it into, you've got this side, you've got this 2 as well. And now the other side, the last, that has to be r theta. Radius was 15 and the theta was 2 pi minus 8.47. You just need to do the calculations or, and you'll get the perimeter. So that is how we're going to solve this question, right? Now, almost half of this paper, right, up till, we've done almost half of this paper up till question number 6. And we'll get to question number 7 in the next part of this video. Thank you very much. Hello, this is Farhan Shakil from the Republic 2.0, and today we've come to you with the third part of this Edexcel May 2025 exam video. In the last video, we've solved up till question number 6, I guess. And now today we'll start from the question number 7, right? So, the last time we've talked about trigonometric questions and the other ones, and now we've got this question number 7. Figure 3 shows a sketch of the part of the curve C1. It has an equation y is equals to f of x, where f of x is a cubic function, and it is passing through the origin and cutting the x-axis at x is equals to 4. So you can see that this cubic function only got 2 x-intercepts. So the function is going to be y is equals to x square times x negative 4 times by a. That should be the standard form of this cubic function whenever it is going to have 2 x-intercepts. So now what we're going to do, it is passing through the points 10 and 120. By plugging these points in, I'll get myself a. So in place of y, I'm going to write 120. In place of x, I'm going to write 10 square times 10 minus 4. And I'll be left out with 120 is equals to a times 100 times 6. So now, if I just want to solve it down, I must be having a is equals to 120 divided by 100 times 6, which is going to be something like, 6 times 20 is 120. This 0 cancels out by this 0, 2 times 1 and 2 times 5. So the answer of A has to be 1 by 5. So what is going to be the f of x? The f of x is going to be 1 by 5 x square times x negative 4, right? And now I've got the curve C2. It has an equation y is equals to 1.2 x times 8 minus x. You can easily see that this is a quadratic function. On the following page, there is a copy of the figure 3 called diagram 1. On diagram 1, sketch the curve of C2. So before sketching the curve of C2, I need to write it in a completing square. So first of all, I'm just going to write it like 1.2 times x is going to be something like, if I'm not wrong, it has to be 9.6x minus 1.2 x squared, right? That is how I'm going to write this thing down. And, by writing it down, like by taking negative 1.2 as common, I'll be left out with x squared minus, since I've taken 1.2 out as common, so x squared minus 8x probably. So now I'm going to write it in a completing square form. So y should be equal to negative 1.2 bracket x minus the half of 8 by 2 square, and minus 8 by 2 square as well. We've got the brackets closed now. And now I'm going to simplify it down like negative 1.2 times x minus 4 square. And over here, 8 by 2 is going to be 4. 4 square has to be 16. So I've got this expression. And now I'm just going to write it down like y is equals to negative 1.2 times x minus 4 square, and then plus. Now 1.2 times 16 is going to be something like, I guess 17.2. 16 times 1.2 would probably be 16 times 1.2. 16 times 1.2 is going to be something like 19.2, right? So we've got these curves. So what does that mean? The y-intercept is going to be 0 minus 4 square, whatever y-intercept you can have for y-intercept. For y-intercept, plug in x equals to 0. So 1 minus 1.2, 0 minus 4 square plus 19.2. And I would be having something like negative 1.2. 1.2 times 16. That has to be something like negative 19.2 plus 19.2. And that comes out to be 0. Now, similarly, if you're looking for the x-intercepts, you just need to plug in x equals to 0. And y equals to 0. So for x-intercepts, you must be having, for x-intercept, I can even use this simple equation. So x must be 0 and 8, right? So I've got x, since 0, 1.2x times 8 minus x. So x should be either 0 or x is equals to 8. That is how the x-intercept work like. So aparting from that, we just need to draw that down. So we have got 0 over here. We've got something like, this was 4. So this one should be something like 8. And since the, the maximum of this curve, if you're looking for the maximum of this curve, that has to be 4 and 19.2, right? So 4 and 19.2 must be somewhere up over there. So we just need to plot it down, a quadratic equation like this. So that is how the quadratic equation might look like. Now in the C part, this was the B part. In the C part, we need to use algebra to find the coordinates of the points where C1 and C2 intersect, show each stage of your working. So we've got one of our equation looks like this, and the other equation looks like this. So we just need to simplify them. We can simply equate them up to get the x coordinates. And once we've got the x coordinate, we can eventually get the y coordinates as well, right? So in the C part, for points of intersection, we've got the points of intersection equating, and for the point of intersection, we need to equate above x's. So once, the other one equation that we had was 1.2 x times 8 minus x, 1.2 x times 8 minus x, and we should keep it equal to something like 1 by 5 x squared times x minus 4, 1 by 5 x squared times x minus 4. So now what we can do, first of all, we can simply cancel out this x with this x, right? This x has to be 0. Then we have got 1.2 times 8 minus x is equals to 1 by 5 times x squared minus 4x. Now I'm going to cross multiply these things, right? 5 times 1.2 would eventually be, if you're looking for 5 times 1.2, that should be 6. 6 times 8 minus x is equals to x squared minus 4x. 6 times 8 has to be 48, and 6 times x has to be 6x is equals to x squared negative 4x. Now I'm just going to simplify this equation, and I must be having x squared negative 4x, positive 6x, and negative 48 is equals to 0. And that would be x squared plus 2x negative 48 is equals to 0. So everybody knows that's 6 times 8 times 6 is 48. So I can write it down like x squared plus 8x minus 6x minus 48 is equals to 0. The common thing between x squared and 8x has to be x, and you'll be left out with x plus 8. Negative 6 times x plus 8 as well equals to 0. So the two x coordinates that you'll be having should be x is equals to 6 and x is equals to negative 8. That is how we're going to talk about these x coordinates. And once you've got these x coordinates, you can plug them in any one of these equations. And I'll probably be using, let it be this one, right? So since y was equals to 1 by 5 x squared times x minus 4, I'm going to plug both of these values in this equation. So y is equals to 1 by 5 times 6 squared times 6 minus 4, and y is equals to 1 by 5. Sorry. So you've got 1 by 5 times x, that has to be negative 8 square, times negative 8 times negative 4, right? So you have got y is equals to 36 by 5 times 2, and y is equals to 1 by 5 times 64 times negative 12, right? So the answer of this thingy has to be 2 times 36 is 72 by 5. And the answer of this thingy has to be something like, 12 times 64. That has to be 768. So 768 negative divided by 5. So these are going to be the y coordinates, and the 6 and 8 were the x coordinates. So that is how we're going to try out this question. Now we have got this question number 8. The curve has equation. The point lies on the curve, given that the derivative of that curve is 3 root of x plus kx square, where k is a constant. The equation of the tangent to the curve at P, right? So what does that mean? That this line and this curve has a common point, that is P. It has an equation 10x plus c, where c is a constant. Show that k is equals to 1 by 4. If both of these curve and this line are tangent, what does that mean? Their gradient has to be the same. So if you're going to compare this equation with y is equals to mx plus c, the gradient comes out to be 10. So what does that mean? That the gradient of this curve would also be 10, because the curve and the line are tangentially parallel to each other. So I'm going to plug in f of hash x equals to 10 is equals to 3 root of x plus kx square. We've been given by the point that is p, 4 and 12. I'm going to plug that point in as well. So 10 is equals to 3 times root of 4 plus k times 4 square. So you'll be left out with 10 is equals to 3 times 2, that is 6, plus 16k, right? And now I'm just going to simplify that down. So I must be having 10 minus 6 is equals to 16k, 4 is equals to 16k, and k comes out to be 1 by 4. So that is how I'm going to get myself the value of k. Once you have got k, you have got y is equals to 10x plus c, where c is a constant. We need to also find out the value of c. What we can do, since I just told you that the curve and the tangent are parallel, the curve and this line are tangent at this point. So this must be a common point, right? So I'm just going to plug in this point into this equation, and I'll get myself the c. So a second part is y is equals to 10x plus c. We have got the point that is 4 and 12. So 12 is equals to 10 times 4 plus c. That comes out to be 12. 10 times 4 is 40. When you take away from both the sides, 10 minus 40 is equals to c, and c comes out to be negative 28. So that is how you'll get yourself the curve. Now in the p part, we need to find f of double hash x at p, and we need to find out the second derivative. So if you remember, we've already got the derivative, and that was f of hash x is equals to 3 root of x plus kx square. K was 1 by 4x square. We need to differentiate it again because he's asking us for the second derivative. So f of hash x is equals to 3 root of x, what is going to be the differentiation of root of x? It must be 1 by 2 before that, then x by 1 by 2 minus 1. Similarly, what is going to be the differentiation of 1 by 4x square? 1 by 4 as it is, power behind x, and then 2 minus 1. So you will have the final answer, f of double hash x is equals to 3 by 2 x to the power of negative 1 by 2. 2 cancels out by this thing, and you must be having 1 by 2 x. The thing is that we need to find the second derivative at the point P, and point P was 4 and 12. So I'm just going to plug that in as well. So f of double hash x is equals to 3 by 2 times 4 to the power of negative 1 by 2 plus 1 by 2 times 4. And now I'm just going to work this thing down. So I must be having 3 by 2 times, 4 to the power of minus 1 by 2 can also be written as under root 4, something like this, then plus 2. By sorting it down, under root 4 would be 2. 2 times 2 has to be, 4 as well. So 3 by 4 plus 2. Then by just taking their LCM, I must be having 4, 3 plus 8. That must be 11 by 4. So that is the second derivative of x at the point 4 and 12, right? Now we need to find out f of x. So we've already got f of hash x. How can we get f of x back? By just integrating it on both the sides, right? So by integrating it on both the sides, I must be having, since for the c part, I've had f of hash x is equals to 3 root of x plus kx square, 3 root of x plus kx square. If we have got this expression, what we're going to do, we just need to integrate it to both the sides. So f of hash x, and over here, 3x to the power of 1 by 2 plus the value of k was 1 by 4 x square times dx. The integration of f of hash x would eventually become f of x, and that's going to be 3 as it is, x to the power of 1 by 2 plus 1 divided by 1 by 2 plus 1 plus 1 by 4 x to the power of 2 plus 1 divided by 2 plus 1, and then we're going to add c into it, right? So I'll be having an expression f of x is equals to 3x to the power of 3 by 2 divided by half plus 1 has to be 3 by 2 as well, plus 1 by 4 x to the power of 3 divided by 3 plus c. And then we can get f of x is equals to, 3 cancels out by 3, so 2x to the power of 3 by 2 plus, x cubed divided by 12 plus c. So the thing is that now we do not have c, so we need to find out c first. So at the point, the point was 4, and if I'm not wrong, the other coordinate was 12, right? So I'm just going to plug that point in. In place of f of x, I'm going to write 12, 2, 4 to the power of 3 by 2 plus 4 to the power of cube divided by 12 plus c. Now I'm just going to simplify that down, and it must be having 12 is equals to 2 times, 4 is 2 square. That square should cancel out by this 2. Then we'll be left out with 2 cube, and that's going to be 8. Plus 4 cube is 64 divided by 12 plus c. And now I must be having something like 12 is equals to 16 plus 4 3s are and 4 16s are plus 16 by 3 plus c. So the value of c comes out to be 12 minus 16 has to be minus 4 on the other side, and then minus 16 by 3. I'm just going to simplify that down. I must be having 3 as an LCM, negative 12, negative 16, and that comes out to be negative 28 divided by 3. That is the constant of integration. So our final function would just eventually become, everything like that, but just over here in place of c, you're going to write negative 28 divided by 3. That is how we're going to solve this thing down. Now we have got the next question, that is question number 9. In question number 9, you've got a C1 curve and a C2 curve. And having these two curves, we need to describe the single transformation that would transform the graph with equation y is equals to under root x into C1. Well, y1 was under root 2x, right? And now we have got under root x. So what kind of a transformation this is? This is stretch along y-axis by under root 2, right? Initially, we had 12 minus root of x, and now to get rid of this 12, we should be subtracting 12 on this from this function. So what does that mean? That you need to move this C2 downwards by 12 units. You need to move this curve downwards by 12 units, right? So these are the transformation. You just need to write them down, do not draw them, right? They're just asking you for the description, not the drawing. Now the B part, the graph C1 and C2 meet at a point. Show that the exact coordinate of P is a solution of. Well, C1 and C2 are meeting at a point, so we just need to equate them up. I must be having under root 2x is equals to, and the other thing is 12 under root 12 minus x. I'm going to move this under root x to this side, and I must be having under root 2x plus under root x is equals to under root 12, right? And now I can see I can have under root x as a common, and I'll be left out with under root 2 plus 1 is equals to 12, right? Now we need to divide it on both the sides. So under root x must be equal to 12 divided by under root 2 plus 1. Now, if you remember, we cannot really, talk about the square root in the denominator. So what I'm going to do, I'm just going to multiply under root 2 plus 1. I'm just going to rationalize it. So under root 2 minus 1 divided by under root 2 minus 1. And now I must be having under root x is equals to 12 times under root 2 minus 1 divided by under root 2 square. And then I must be having minus 1 square. Under root 2 square is 2, 2 minus 1 has to be 1. So under root x eventually comes out to be 12 under root 2 minus 1. And that is what he was asking us. Now, in the simplest form, find the exact coordinates of P. So let me get P from here and then I'll get Y. So to get X, I need to square both the sides. For the C part, I'm just gonna squaring both sides. So by squaring both the sides, I must be having under root x square is equals to 12 times under root 2 minus 1 ka whole square. This square cancels out by the square root. You must be having x. 12 square has to be 144. And under root 2 minus 1 square, if you expand that down, you must be having 2 plus 1 minus 2 under root 2. So the answer of x has to be something like 144 times 3 minus 2 root of 2. That is x. And now you're looking for y. For example, if you're looking for y, you've got 12 minus root of x and you've got under root 2x. So you can just simply plug in their value, right? So y has to be 12 minus, and the root of x, if you remember, was 12 root of 2 minus 1. And now we just need to simplify that down as well. So y is equals to 12 minus 12 root of 2 plus 12. And that comes out to be 24 minus 12 root of 2. So the x coordinate of P would be this number, and the y coordinate of this P should be this number. So that is how we're going to simplify this question down. Now, we've got the last question now. And the last question says that k minus 1 x6 plus 4x cubed plus k minus 4 is equals to 0, where k is a constant. Find the exact solution to the given equation for k is equals to 4.5. If k is 4.5, so k minus 1 should be 3.5 x to the power of 6 plus 4x cubed, and then k minus 4 should be 0.5 is equals to 0. Well, since this is something like a more than a quartic equation, it has a degree 6. So we can suppose that y is equals to x cubed. So this equation would eventually become 3.5 y square plus 4y plus 0.5 is equals to 0. Well, solving this equation by factorization or complete exponent would be a bit hard, so I'm just going to apply the formula. So y is equals to negative 4 plus minus root of b square. That has to be 16 minus 4 times 3.5 times 0.5 divided by 2 times 3.5. Simplifying this down, I must be having y is equals to negative 4 plus minus root of 16. 4 times 0.5 has to be 2, and 2 times 3.5 has to be 7. So 16 minus 7 divided by 2 times 3.5 has to be 7 as well. So now, by just solving this down now, negative 4 plus minus 16 minus 7 has to be 9, and the square root of 9 has to be 3 divided by 7. So the two answers of y that I must be having should be negative 4 plus 3 has to be negative 1 upon 7, and the other answer for y, negative 4, negative 3 should be negative 7 upon 7, and that should be negative 1. Now I'm just gonna, take the plug the values back into it. So I suppose that y was equals to x cube, right? So x cube is equals to negative 1 by 7, and x cube is equals to negative 1. Their answers are in the form of iota. You can just simply keep them the same thing is. So you've got the cube roots over here, you've got the cube roots over here, cube roots over here, and cube roots over here, right? You can either solve them like this, or you can apply the formulas as well. So these are the possible answers for x. Now find a set of the possible values of k for which the given equation has no real roots. So we need to solve this equation down for which this equation has no real roots. No real roots means that this equation would not be having any sort of, uh, its discriminant must be less than 0, right? So what I'm going to do, I'm just going to rewrite that equation. And I must be having, for the p part, k minus 1 times x to the power of 6 plus 4x cubed plus 4x cubed plus k minus 4 plus k minus 4. First of all, I'm going to transform this equation into a quadratic one, so I can rewrite it as k minus 1 times y square plus 4y plus k minus 4 is equals to 0. Now, for this equation to have no real roots, the discriminant should be less than 0. I'm going to plug the values in. B is 4. 4 square has to be 16 minus 4. A is k minus 1 and B is k minus 4. It should be less than 0. I'm just going to sort it down. So 16 negative 4 times k square negative 4k negative k plus 4 should be less than 0. 16 negative 4 times k square negative 5k plus 4 should be less than 0. And now 16 negative 4k square plus 20k negative 16 less than 0. This 16 and this 16 would get cancelled out, and you can have negative 4 as common. So you'll be left out with negative 4k as common. So you'll be left out with k minus 5 less than 0. So from here onwards, your k must be 0 or your k must be 5. So 0 to 5 are the possible values of k, and that is what we've been looking for. So that is how we're going to do the paper 2025. That is the latest paper that we can have. I hope you have understood all the questions. If you got any questions, please comment. I'll respond. Right. Thank you very much.